Good day, students. Welcome to mathgoodserve.com. In this clip, we're going to be going over problems 6 to 10 of the 2008 AP Calculus Multiple Choice Release Questions. All right, let's take a look at number 6. It says, let f be the function defined here. Which of the following statements about f is true? So the first one is f has a limit at x equals 2. So for this first option, we are trying to find the limit as x approaches 2 of this function right here. So a good way to approach a piecewise defined function is to give yourself a visual so you can really understand what is going on here. Okay? So at x equals 2, something interesting is happening. We have this function that exists before and after 2. Have a function right there. But at x equals 2, we have a value of 1 somewhere here. Okay, it's not continuous. Okay, so the first question is, what is the limit as x approaches 2 of the function right here? So to do this, we're going to take a look at this piecewise defined function. When x is approaching 2, x is not at 2. So we're going to be considering this first equation of our piecewise defined function. Okay, so that basically means that the limit as x approaches 2 of f of x is equal to what you get when you evaluate this function at x equals 2. Okay, so you're going to have 2 squared minus 4 divided by 2 minus 2. All right, and then when you work this out, you end up with 0 over 0, which is indeterminate. So what does that mean? Does that mean that the limit does not exist? The answer is no. This is an indeterminate form, so we have to see what we can do to basically rewrite it in a way where the limit might exist. Okay, so let's go ahead and go back to the original function, x squared minus 4 over x minus 2. And what you notice is the numerator is a difference of squares. Okay, so what is the factorization form of a difference of squares? So let's review that real quick. A squared minus b squared is a difference of squares that factors into a plus b times a minus b, what you learned in algebra 1. Okay, so you just root both terms and then you express it as a sum of products. So the factored form of the numerator, to write the limit as x approaches 2, is x plus 2 times x minus 2 over x minus 2. All right, so the x minus 2's cancel out, divide out. So you notice that we have a removable discontinuity at x equals 2, the value that we were approaching. So we now have the limit. The limit as x approaches 2 of x plus 2 is simply you plug into 2 plus 2, which is 4. What does this mean? It means that the limit exists and it's 4. So statement number 1 is true because the function has a limit at x equals 2. Question number option 2, f is continuous at x equals 2. What does that mean? A function is continuous if the limit function is continuous at a point if the limit as x approaches that point, in this case is 2 of the function, is equal to the value of the function when you evaluate the function at that value that x is approaching. Okay, so the limit as x approaches 2 is equal to the value of the function that x is 2, then the function is continuous. All right, so what is the limit as x approaches 2 of this function? We already determined it in part 1 as 4. Is 4 equals f of 2. F of 2 is that point there, the point 2 comma 1. Okay, f of 2 is equal to 1. Is this statement true or false? This statement is false. Since the limit of the function is not equal to the value of the function, here we have a removable discontinuity situation. So the function is not continuous. So option number 2 is false. Now, how about option 3? F is differentiable at x equals 2. A condition for differentiability is continuity. Okay? Remember, there are 4 cases where a function is not differentiable. We have a vertical tangent. We have a corner or a cusp, or what? A discontinuity. All right, so a condition for differentiability is discontinuity. Since the function is not continuous at x equals 2, guess what? The function is automatically not differentiable there because you can differentiate a function at a discontinuity. The only statement that is true is statement number 1. Answer is option letter A. All right, let's take a look at question number 7. It says a particle moves along the x-axis with velocity given by v of t equals 3t squared plus 6t for time t greater than or equal to 0. If the particle is at position x equals 2 at t equals 0, what is the position of the particle at t equals 1? So you want to remember x, v, a, j. So position, velocity, acceleration, jerk. When you're going from position to velocity, what you're doing is you're differentiating with respect to time. Okay, the same applies to going from velocity to acceleration and acceleration to jerk. When you're going from velocity to acceleration, from velocity to position, you're doing the inverse of differentiation, which is integration. So you're integrating from a to b, or some function plus a plus an initial condition. Okay, we can call it plus c. All right, so in this situation, we're given a velocity function, we're given an initial position, and we're asked to find the position of a particle at t equals 1. So what operation relates velocity with position? If we were given the position function, we differentiate that to get the velocity. But in this case, we're given the velocity function. So we have to integrate the velocity function to get the displacement or the change in position, sorry. All right, so let's write down what the formula is. It's going to be a definite integral. So the integral from a to b of the velocity function is basically going to be change in position. The antiderivative of velocity is position evaluated at the upper limit minus the antiderivative of velocity, which is position, evaluated at the lower limit. Okay, so this is the formula that we're going to be using to find the position at t equals 1. In our case, for number 7, a is going to be 0 and b is going to be 1. Okay, all right, so let's go ahead and apply the formula. We know what b of t is, so we're going to find the integral from 0 to 1 of the velocity function, 3t squared plus 6t. The t is basically the change in position, so the final position is going to be x of 1 minus position at t equals 0, x of 0. All right. Okay, so let's see what we have here. Let's integrate the velocity to get 3t squared over, actually 3t to the third over 3. What I'm using here is the power property for integrals. Okay, so if you find that antiderivative, you have 3t to the third over 3 plus 6t squared over 2. All right, that will be evaluated from 0 to 1. We're about to apply FTC part 1 here. Okay, Position at t equals 1, that's what we're looking for. Position at t equals 0 is 2. So x1 minus 2. That's equivalent to that c. See that c we have here? This integral is your position, displacement, and then this is you're adding the initial position. Okay? Now, let's go ahead and simplify this, and then we can evaluate. So we have t's divide out. So we have t to the third plus, 2 goes into 6 3 times, right? So we have 3t squared evaluated from 0 to 1 plus 2 should give us our position when t is equal to 1. Okay, so let's go ahead and finish this up. So x of 1, applying FTC part 1, we're going to evaluate the antiderivative at the upper limit minus the antiderivative evaluated at the lower limit. Okay, so just plug in those limits of integration into the antiderivative. Plus 2. So here we have 1 to the third is just 1 plus 3 times 1 squared. 3 times 1 squared is 3 times 1, which is 3. So that's 4. 1 plus 3 is 4 minus 0. Final answer is 4. Your answer is option letter A. All right, let's take a look at question number 8. Question number 8, it reads, if f of x is equal to cosine 3x, then f prime of pi over 9 is... So to find f prime of pi over 9, there are two parts to it. Part 1, you find the derivative, so find f prime of x, and then part 2, you evaluate f prime of pi over 9. So the tip here basically is you do your calculus before arithmetic. Okay, so keep this in mind. Anytime you are asked to find the derivative at a particular point, do the calculus component first, basically the differentiation, and then you substitute the value that you find in the derivative at. If you do the reverse, you end up with 0. Okay? Okay, all right, let's keep that in mind. Now, first things first, let's find the derivative of the function cosine 3x. Now, if you're taking a look at, this function, you will notice that it is a composite function. Okay? Before differentiation, you want to closely inspect your function to see what the correct formula to use to differentiate it. All right, so what is the first thing that comes to mind when you see a composite function? You want to use the chain rule or the outside-inside rule. Okay, so our outer function in this case is cosine x. Its derivative of cosine is negative sine. Don't forget that. The inner function is the linear function 3x. And its derivative, g prime of x, is 3. So the chain rule basically is as follows. If you find the derivative of a composite function, let's write that down so we don't get confused. So f of g of x prime is what? It's the derivative of the outer function evaluated at the inner function as the outside, and then times the derivative of the inner function. Okay, so this is what the chain rule is. All right, let's apply that here. F prime of g of x just simply involves plugging g into the derivative of f. So just plug in 3x into sine x, and then you multiply it by 3, okay? So we have f prime of g of x is negative sine 3x. And then we'll multiply that by its derivative, which is 3. So this is f prime of x. Okay, if you want to make it look pretty, it's negative 3 sine 3x. Now, we're going to advance to We're going to advance to part 2, which is to evaluate the derivative at a particular point, in this case pi over 9. So f prime of pi over 9 is equal to negative 3 sine 3 times pi over 9. All right, so that becomes negative 3 sine. We can reduce this. The argument of your sine function, 3 goes here, 1, 3 goes here 3 times. So we have negative 3 sine pi over 3. All right, and then that gives us negative 3 sine of pi over 3 is root 3 over 2. Don't forget that. And then you multiply. Negative 3 over 1 times root 3 over 2 is negative 3 root 3 over 2. Our correct answer is option letter E. All right, let's take a look at question number 9. It says the graph of the piecewise linear defined function f is shown in the figure here. If g of x is the integral from negative 2 to x of f of t dt, which of the following values is the greatest? Now, what you want to remember is that an integral is basically the area between a function and the x-axis. All right, and then do not forget the area of a trapezoid formula. Let's refresh our memory on that. So a key formula we're going to be using for this problem is the area of a trapezoid. Area of a trapezoid is 1/2 sum of parallel lines times the height. And then we know what the area of a triangle is, right? Area of a triangle is 1/2 base times height, or base times height over 2, whichever one you want to use. Okay, so we asked to determine which of these is the greatest. So let's start with A. So for A, we're looking for g of negative 3. All we'll simply do is plug that into this integral expression. Integral from negative 2 to negative 3 of f of t dt. Now, what you notice is that whenever we're integrating and we're approaching it graphically, what we're doing is we're going from left to right. That's how we sweep our areas, okay? This is negative 3, negative 2, negative 1. Okay, we're going in increasing order. But if you take a look at the limits of integration here, it's not an increasing order. Okay, we have the bigger number as the lower limit, and then the smaller number as the upper limit. That is no good. Okay, so if we want to find the integral, we have to fix that problem. So what we do is we have to switch it to make sure that the limits of integration is in increasing order. So from negative 3 to negative 2, okay, because we're integrating from left to right. That's how we're sweeping our area. So f of t dt. Now, what happens when you switch the order of integration? Whenever you switch the limits of your definite integral, you have to introduce a negative sign. All right, so now we have it set up nicely. We're now going to find this area here, the area from negative 3 to negative 2 beneath this line. What kind of geometric figure is that here? This is a trapezoid. Okay, this is B1, which is 1, and B2 is 2. The height is 1. So what's the area of that trapezoid? Is 1/2, as indicated up here. Base 1 as 2 plus base 2, which is 1 times the height. What's the height? 1. All right. If you work that out, you have 3 times 1 times 1 is 3 over 2. 3 over 2. Don't forget your negative sign. Minus 3 over 2. All right. Option letter B. Let's see how big that is. G of negative 2. G of negative 2 is equal to the integral from negative 2 to negative 2 of f of t dt. How much area do you cover when you have 0 height? You have 0 area. Okay, because whenever you multiply 0 by whatever your base is, in this case, you have two identical bases of length -2. When you multiply that by 0, you end up with 0. Or anytime your limits of anytime the limits of a definite integral are identical, the resulting integral value is 0 because you're not covering any area at all. Okay, so that's the size of g of -2, option B. Now let's take a look at option C. Option C is g of 0. What is g of 0? G of 0 is an integral starting from -2 all the way to 0 of f of t dt. All right, so let's see. We're going from -2 all the way to 0. So we are looking at this geometric figure right here. That is also the trapezoid. Okay, so we have B1 is 1 and B2 is 2. Similar to that, but this has a longer height. This has a height of 2. Okay, so the integral is going to be 1/2 sum of parallel lines 1 plus 2 times height of 2. Okay, so these two 2's cancel out and you end up with 3. Now let's take a look at option letter D. G of 1. What is G of 1? G of 1 is the integral from -2 to 1 of f of t dt. That's what G of 1 is. All right, so what are we looking at for that one? For option D, we're going from -2 all the way to 1. So all we're doing is taking the answer we got from C, which is -2 to 0, and we're adding on the area from 0 to 1. Okay, so we have a triangle here. The base is 1, the height is 2. So the area of this triangle is basically 1/2 base times height. 1/2 of 1 times 2, which is just 1. Okay, so this integral right here is going to be 3. The area of the trapezoid from -2 to 0 plus 1, the area of this triangle right here, and the answer is going to be 4. All right, lastly, option E, we're looking for g of 2. Okay, so g of 2 is the integral from -2 to 2 of f of t dt. So you notice what we're doing is we're adding more area, okay? So for E, we're adding more area to what we already have. So starting from -2 all the way to 1, we know that that is 4. But when you're going from 1 to 2, what happens? You are now underneath the x-axis. How does that impact the area? The area, this area and this area are identical. Okay, this has an area of 1. Guess what? The area underneath the x-axis has a negative height. So it's going to have an area of -1. So this is 1/2, if you want to do the work. 1/2 base, 1 times height, -2 is equal to -1. Okay, so all we're just going to do here is take that previous answer, integral all the way to 1, which is 4, and we add the negative area, -1, and the answer is 3. Okay, so which is the biggest? The biggest is option letter D. This is the greatest. All right, let's take a look at question number 10. It reads, the graph of the function f is shown above for 0 to 3. Of the following, which has the least value? So we're looking for the one with the smallest value. All right, so these are the names I'm going to be using for the different parts of these options here. So the integral from 1 to 3 of f of x dx, let's call that the exact area. Okay. And then the left Riemann sum, let's call that LRAM, as you already know. Right Riemann sum RM, midpoint Riemann sum MRAM, and trapezoidal sum, let's call that trap. Okay, now the question is which has the least value? So what I did here is I created 4 graphs so that I can give you a visual as to the comparisons that I'm going to be doing. Actually, I need 5 graphs since we have 5 options. Okay, so let's take a look at option A. So option A is the integral from 1 to 3 of f of x dx. Now this is the exact area. Okay, now what does that look like geometrically? The exact area is simply the area between the curve and the x-axis. Okay, that's the exact area, the integral from 1 to 3 of f of x dx. All right, now let's take a look at, so that's A. Take a look at option B. So for option B, we have LRAM, the left rectangular approximation. So let's sketch what that looks like and see how that compares with option A. So we just trace starting from the left endpoint. We just extend a line to the curve. So 1, 2, 3. Okay. So that's the upper left corner of your rectangle. So we're gonna go like this. That goes to the third rectangle. It's just a sketch, it's not perfect. And then this is your second rectangle. And then there goes your first rectangle right there. Now, what do you notice about this approximation right here? What do you notice? What is going on? This approximation is an overestimate. It's bigger than the exact area. Why? You see the rectangle has some areas outside above the curve. So LRAM is an overestimation. Okay, so let's write that down. This is an overestimate. So what does that mean? It is bigger than option A. We are looking for the smallest. Okay, that's the goal. Okay, option C is the right rectangle approximation. All right. Now, what does that look like? Let's go ahead and draw a sketch. We're going to start from the right end this time. Okay, right end to the curve. Okay, that's going to be the right upper corner. The point where the line touches the graph is the right upper vertex of your rectangle. Okay, so you have it like that. That's the third rectangle, your second rectangle, and your first rectangle. Now, what do you notice? The area of the rectangles has some space between them and the curve. So this is an underestimate. Okay, underestimate. What does that mean? It is smaller than these two. This is an overestimate, is bigger than this one. This is an underestimate, which is smaller than these two. So this is an ideal candidate right here. Okay, next one is the midpoint rectangular approximation, MRAM. So to draw that one, you just simply pick the midpoint of your subintervals and trace them to the graph. And that will be the midpoint of the upper side of your rectangle. Okay, you have it like that, and then like this. This is not perfect. So this is the first rectangle right here. This is the second rectangle right here. And then your third rectangle somewhere here. Bring that down a little bit so it looks better. Okay, so that's basically what it looks like. It doesn't have to be perfect. Okay, so how does this compare? MRAM is actually between, this is the midpoint rectangular approximation, option D. Option D, MRAM is somewhere between between LRAM and RRAM. Okay, so let's write that as an inequality. It's between MRAM, LRAM and RRAM. So it's between LRAM and RRAM. So as an inequality, we have RAM at the bottom. RAM is the smallest one here, and that is less than MRAM, and MRAM is less than, in this case, the RAM. Okay, let's take a look at the last one, option E, which is the trapezoidal approximation. That one is simply the average of LRAM and RRAM. Okay, so this one is LRAM plus MRAM divided by 2. Okay, so if you average LRAM and RRAM, how does the resulting average compare to the lower of the two? The average is going to be bigger. The average is going to be right between these two. So this trapezoidal approximation is automatically greater than the right rectangle approximation. Okay, so let me show you what it looks like visually. So your trapezoidal approximation, just draw the lines to the graph like that, and then like that, and then you put in your trapezoids. Okay, so let's see what that looks like. So first trapezoid, second trapezoid, and third trapezoid is basically the average of these two. Okay, so what is the smallest out of all of them? We can clearly see that the right rectangular approximation is the smallest. Okay, so our answer is option letter C. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you have any questions about the contents of this presentation, just include your questions in the comment section below, and we will be glad to assist you at our earliest convenience. Do not forget to subscribe to our channel so that you can get updates to the remainder of this review series and other great tools to help you prep for the AP Calculus exam. More clips can be found on mathwithserve.com, including our interactive practice tests, so go ahead and check it out. Thanks again for watching, and have a wonderful day.